In this 9th lecture, we are going to talk about correlation and correlational analysis, a form of inferential statistics. What is correlation? Correlation is the association between two variables such that the variation in one variable is accompanied by the variation in another. It is accompanied. They exist together. So, as the value of one variable increases, the other variable also has a variation. It could be in the same direction, increasing or decreasing. If two variables move on the same direction up and down, then we say they are positively correlated. Which means, let us say, my example of the number of hours of study and marks in an examination. If the marks in an examination goes up as the number of hours goes up, then we say there is a positive correlation, which means as the number of hours comes down, also the marks in an examination is assumed to come down. And then, so there is a correlation, positive correlation. But it could be negative correlation. In say a variable A, as it increases, the variable B always comes down. It goes in the opposite direction. That means there is negative correlation. So what actually happens in a correlational test? If we look at the screen, we see a graph with two variables. Variable 1, average temperature of the month. Variable 2, number of malaria cases. Here indicated in terms of pluses and minuses on the graph. So you can see a trend as one variable increases, goes right and up. The other variable also increases in a similar fashion. So what does it show? That this graph is suggesting, we will call this scatter plot technically, shows that as one variable varies, increases or decreases, the other variable also has a similar direction of variation. So in this case, this graph, just an imaginary graph, is showing that there is a positive correlation between temperature and the number of malaria cases. Now, this is simply correlation. Now, some points of relevance in talking about correlation. If you are going to measure the correlation between two variables, you should have measured these two variables in terms of scale variables. We need two variables that have actual scores within them, actual units of degrees within those numbers. You cannot carry out a correlational test using Pearson's R if you have one nominal variable and the other scale variable. Because nominal variable is going to divide the participants into two groups or more, and then you are going for comparison. But here you are comparing the same population or the same sample having scores on two variables, and we are seeing whether the variation, the changes in this variable coincide with each other. That is correlation. Now, correlation is measured in terms of Pearson's R. And in the SPSS, you would follow this pattern. You will go to Analyze menu, and there will be an option to correlate. You would choose bivariate option to calculate Pearson's R for the data you have entered. And for sure, bivariate refers to two variables, at least two variables. And therefore, you enter into the SPSS two data from two variables. And Pearson's R will be reported in terms of the letter R, and the value of R can range from 0 to 1. So scores between 1 and 0 are simply decimal points. So if you have 1, then there is 100% correlation. And if you have 0, then there is no correlation. And if you have anything in between, then you have correlation at varying levels. So when the R value is reported, first thing we notice is what is the level of correlation. And together with the level of correlation, you have to see the p-value. The p-value means that that correlation was statistically significant or not. So as we have said in the previous lecture, if the p-value is less than 0.05, then this correlation is significant. So once it is significant, then we are looking at the level of the correlation. The third thing that we need to look at in interpreting the correlation is the balance, whether it is minus or plus, whether it is negative or positive. And all this will be reported by Pearson's R. Pearson's R will report an actual number ranging from 0 to 1 in decimal points. It will report the valence, whether it was negative or positive. And thirdly, it will also report whether it was statistically significant or not in terms of p-value. And when we consider the correlation, we need to take into consideration all these three dimensions. And we need to report these three dimensions when we are talking about correlation. So what is actually happening within a correlational analysis? You can see a complicated formula. R is equal to sum of x minus x mean and y minus y mean and all that. But what is actually happening? As we have said in inferential statistics, it is finding out for possible error in the data. It is finding out whether these mean scores that we are now correlating and the range of the scores can be taken seriously or not. It is looking for the standard deviation, it is looking for the distribution of the scores, and we are assuming whether what is true of the sample is true of the population. A final point about correlational fallacy. Correlation does not mean cause and effect relationship. Correlation means there are two variables and the variation in one variable is always accompanied by the variation in another variable. But that does not mean variable A is causing variable B. We define cause and effect relationship in terms of that variable A can be attributed to be the cause of variable B if the presence of variable A is always accompanied by the presence of variable B in such a way that variable A precedes variable B. Then we can isolate variable A as a cause of variable B. But if variable A and B exist together and their variation is only accompanying each other, then we do not really know which variable is causing another variable. Maybe there is a variable C that is actually causing variable A and variable B. Or variable C is causing variable B, and we have not considered that. So correlational fallacy is a common fallacy in research reports. If you have carried out a correlational analysis, only talk about correlation and not cause and effect relationship. However, using the correlational data, particularly when we have many variables, we can do a regression analysis to find out the predictors. So among things that are correlated, what regression analysis does is which variables are stronger predictors of the outcome variable. This is again not cause and effect, but it is a little more rigorous than correlation. It is predicting. So regression analysis is a development on correlational analysis.